Okay, welcome to Unit 3, Lesson 6, Squares and Square Roots. Here's the warm-up, and they give you these little equations right here. And you can see the answers to these equations in this picture down here. So you're supposed to make a connection between the two. So it says solve mentally. So y equals x squared, that's our traditional parabola. And that's what's graphed there. Oh, it's terrible writing. So it goes through 0, 0, 1 squared is 1, etc. And that's what's happening here in this picture. So it goes through 0, 0, 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. So there's your traditional parabola. So it's asking, what is x? Another way to answer this question is, when is the parabola 4? And you have to remember, and this is important, that when you have the x squared, you're looking for two solutions. So for the first one, x would be what? What squared is 4? Two things. 2, of course, the squared is 4. And what's the other one? Negative 2. For the next one, we have x squared is equal to 2. Okay, so when is it 2? Well, that would be right there. So it's these points where it's 2. So those are not whole number answers. So that's when we have, like, the square root situation. So for this one, x squared is equal to 2. There's two answers that work for that as well. And they would be the square root of 2 and negative the square root of 2. When is it 0? When's the parabola 0? Well, just that one point right there. So 0 squared is the only way to make 0. So there's just one solution for that, but it has to do with the multiplicity idea, the fact that it really is 0 solution twice. Remember, it touches it and bounces. So that's what's going on there. And then the last one is, when is it negative 1? Negative 1 is a horizontal line, right? And it completely misses the parabola. And if you think about that for a second, what are you going to square the same thing times the same thing to be negative? That doesn't exist, right? Because a negative times a negative is positive, and two positives is positive, so you can't really get a negative 1, and you can see that the line never touches the parabola. All right. When you see x squared is equal to 4, you think plus and minus 2. Right? It's the square root of 4, but there's two solutions, the positive and the negative one. We just saw that in the warm-up. When you see the square root of 4 just by itself, don't think two solutions. That just means one solution. So that's just 2. So this does match that, and this does match that. Then Claire's like, oh no, it's plus and minus 2 and all that kind of stuff. No, all of these are wrong. It's just this one. So that's what's going on there. So she's trying to think about this x squared is 4, and then there's plus and minus 2, but no, just by itself, the square root of 4 is 2. Okay, we're going to skip that. This is a graph not of y equals x squared, it's the inverse of it. It's the y is equal to the square root of x, except for they say b is equal to the square root of a. So that's what they're graphing here. So this is notice it's the a axis and the b axis. So if you take the square root of a number, then you get just one solution. And that's what's going to happen here on this graph. See, on the first graph here, we had two solutions because this comes across here, hits the function twice. So there's two solutions, plus and minus 2. But here there's just one arm of this function. There's just one part to it. So if we put in 4, right? So we put in 4, the square root of 4 is 2. There's only one answer to that. So this is the point 4, 2. And that applies to the table down here. Square root of 4 is 2. Square root of 1 is 1. Square root of 9 is 3. Square root of 16 is 4. Now 12 doesn't work out to a nice answer. So 12 is right here. We go up, we hit it. It's about 3.5, but it's not exactly 3.5 because it's an irrational number. It really is the square root of 12. And then, of course, 20 is the same way. You can't take the square root of 20, so you write square root of 20. It's some decimal answer, some irrational number. Okay, so what works for this? Square root of what is 4? So a would be 16. Square root of 16 is 4. So that would be the point 16 comma 4. Well, I can label that 16, 4 is right there. Over 16 up 4. Square root of what is 5? Okay, square root of 25, right, is 5. So I can label that. Go over 25 and up 5 would be right there. So that'd be 25 comma 5. So there's just one answer to these, one thing that comes out. And then the way that this works would be a is 5 to make that match. Okay. Next page here. This is kind of related to the warm-up, and it's just kind of reinforcing that idea. So what squared is 25? There's two answers. So if you go to 25, right, there's this answer over here. The square root of 5 squared is 25. The other answer over here would be negative 5. Negative 5 also squared is 25. So you can see that there's two answers when you have the parabola situation. So what is S? Whoops, I wrote S. S is plus or minus 5, right? It's negative 5 or positive 5. Then T, this would be working backwards. So the square root of 25 is 5. So the square root of 25 is equal to 5. So that means T, it'd be 5 is for S and 25 is for T. So the square root of 25 is 5. But that's saying T is 25. So that's really this point right there again. But it's just one side of the graph. And of course, when is S squared equal to 5? S squared is equal to 5. And then that would be the square root of 5 and negative the square root of 5. That's when it's equal to 5. So if I say, what is this really saying here? It's saying when is the parabola 5? Okay, so I go to 5. When is the parabola 5? The parabola is up to 5 here, and it's up at 5 here. So how do we get those numbers? Well, if you go over the square root of 5, then you would go up 5. And if you go over negative the square root of 5, you would go up 5. So see, when it's written that way, like x squared equals a number, x squared or s squared equals a number, there's two solutions to it. But if it's just square root of a number, there's one solution. So that's kind of the deal with that. Okay, the orange page is basically reiterating what we talked about. If you square something and it equals a number, right, a positive number, there's two solutions. If you're just looking at the square root of 11, it's just the square root of 11. There's no plus or minus to that. Okay, and if we want the negative, we'd have to put it in the front. But if we just have square root of 36, that is 6. But if I have x squared is 36, then I say x is plus or minus 6, because there's two solutions for this, just one answer for that. And that's kind of the separating that out. Okay, the purple page is on this page right here, 296. And so you're selecting all that apply to this problem. That should be pretty good here. And then there's 3 problems here. So find the answer to this one for x, this one for x, and this one for x. Then this is talking about, think about the picture. How do we know that there's 2 solutions, and how do we know there's just one solution to this? And then this is a review question from 3.3. And then this one's important here. What does this mean? People are still kind of struggling with this. So we're going to go over it real quick. Number 5. So we have 8 to the 5/3 power. What does that mean? Well, I sang a little song. Mr. Jackie knows the exponents E-I-E-I-O. So the index, right? And it's easier a lot of times to take care of the index first. So the index is 3. So it means take the cube root of 8, which is just a nice whole number, right? Do that first. Cube root of 8 is some number, right? Then once you get that answer, then raise it to the 5th power, right? And the 5th power means you multiply whatever this answer by itself, right, 5 times. So it's just the same answer over and over again 5 times, but you need to know this answer first. And a lot of times it's easier to apply the index first and then the exponent second. All right, so good luck with this. Hopefully this helps if you weren't in class to understand